welcome to this special edition of Supermicro's Tech Talk series. My name is Peter Rutten, and I am IDC's Global Research Lead on performance-intensive computing solutions and use cases. That includes HPC, AI, and big data analytics. I'm very excited to be joined by product experts from Supermicro to discuss innovations in high-density computing in HPC. Gentlemen, please go ahead and introduce yourselves.
Yeah, thanks for having us, Peter. Great to be here. My name is Michael Ocampo, one of the product managers here that manages the twin systems. And I also manage a team of solution architects that are focused on high-performance computing, NVMe technologies, as well as hybrid cloud.
Yep. I'm Luis Garcia, and I'm Director of Blade Solutions here at Supermicro. Kind of work with teams across the company to identify and bring to market validated solutions on the blades, particularly, especially in this case, for HPC segment. So thanks for hosting it.
So it's great to meet you guys. It looks like you have some interesting systems there today, and tell us a little bit more about what they are and the features that make them suitable for HPC.
Sure, Peter, I guess I'll go first.
Sure, sounds good.
Yeah, so most of our customers already know our twin product family. And today I've brought the latest X12 BigTwin, which is our 2U 2-node configuration. Usually our 2U 4-node system is the most popular selection just because it has more compute density than other types of systems. The SuperBlade being one of the highest density options. But for us, with this configuration, we can support up to 12 Gen 4 NVMe drives. And we have larger heat sinks, so it's very important to be able to accommodate more power, as well as being able to cool down those CPUs, which have been pretty challenging these days as the compute density increases over time. And the other thing to mention here is that we have dedicated I/O, so we have 2x8 on our CPU1, as well as an AIOM slot, which can actually support OCP 3.0 cards, HDR, InfiniBand, 200 gigabit, and we have an additional x 16 Gen 4 slot to have another redundant HDR network or another x 16 card. So overall, we wanted to make sure that we show this subsystem because it is a differentiator in the market. It actually competes even with some 1U systems that are offering all flash with all Gen 4 NVMe drives. So that's kind of a high-level overview of what differentiates this platform in the HPC market.
So thanks, Michael. Yeah, that was great introduction about the twins. It really has an advantage when it comes to storage. And the blades will shine when you're really focused on compute density. Doesn't have the storage that the twins can support. So again, depending on what workload and what are the requirements that the customers have, will be which system is a good fit. So the SuperBlade, again, probably got the highest compute density that you can find with up to 20 server nodes and 8U, and to help contribute to that performance density, it also comes with integrated 200 gig HDR InfiniBand. So without all of the cabling, which can be quite expensive, as you know. So InfiniBand cables are really expensive. So when you factor in the reduced cabling and the high density, the SuperBlade is really targeting kind of that performance density, and price performance that customers are looking for. And then, quite honestly, both systems, Twins and SuperBlade, are really delivering on that performance per watt that HPC customers are looking at. You get from the shared power cooling infrastructure, you get up to like 20% reduction, improvement on power efficiencies over traditional rack mount servers. So again, here we're looking at Intel 2-socket server. It's got a mezzanine option for the 200 gig InfiniBand, comes with 2 onboard 25 gig. This is a SATA model. There's a SAS and SATA model, so the SATA model can support up to 3 upfront hot pluggable drives. Again, if you need more storage than that, the Twins is probably a better fit. If 3 will do it, that's good. One thing I want to mention, customers don't need that InfiniBand we actually have a mezzanine option that comes with 4 onboard NVMe drives. So you can actually have up to 7 NVMe drives in this small blade. But again, you'd have to make the trade-off into, do you want the high-speed networking, or do you need the storage? So if you didn't go with the 200 gig InfiniBand, you could use the dual onboard 25 gig network, which is great for many applications. So that's what I'm going to share with you right now.
All right, great. Thank you for sort of explaining all these features, and I'm sure there's a lot more that we don't have time to go into right now. But what I'm kind of curious about is what kind of customers for whom these features are important are using Supermicro SuperBlade for HPC, and why specifically did they choose SuperBlade?
So sure, I'll go ahead and start off this question. So we have 2 customers that are using the 8U SuperBlade. They're both using the Intel 3rd generation Xeon scalable processors. They're both using 200 gig 8DR InfiniBand. So again, with large configuration. So again, these are customers that are really looking, for that highest density that they can get. Additionally, Osaka University is using direct liquid cooling in their data center. So they have a hybrid supercomputer that is delivering over 16 petaflops of compute. So again, this is great for those when the compute requirement as part of the HPC configurations. Both of them are using these systems to kind of address shortcomings in the past from previous HPC systems, whether it's getting to market faster or being able to provide access to their users without having high utilization and long wait times. So, the supercomputer SQUID system that Osaka University, that was a big concern for them, is being, have high utilization and long wait time. So allowing them to get access to the compute resources in a more timely manner, and being able to have access to the highest performance to be able to do that, those simulation and CAE activities that the system is designed for.
Yeah, very important. Enabling more and more users to get access to these systems. We're seeing that pretty much everywhere, that's a very important factor. Same question really for the Supermicro Twin system.
Yeah, sure. So recently, actually right now, we're deploying 4 smaller clusters. They're not quite as expansive as the SQUID cluster. There's quite a lot of things going on in finance, global management firms, as well as smaller clusters that are expanding. So X12 BigTwin has been very popular because we're able to support higher compute densities than some of our competition without liquid cooling. So we've spent a lot of time doing thermal optimizations, and one of the interesting things with a recent deployment is they actually needed hardware RAID as well as a cache fault. So we needed a way to make sure that the subsystems are cool from front to back, and we had to do make sure that we distribute the heat and we're able to cool down every single component, especially the PCH as well as the cache fault itself, while cooling down a very powerful processor. I mean, we go up to 270 watts. In this configuration, because there was storage, we were supporting about, I believe it was 250 watts or 235 watts, if I remember correctly. So it's been a challenge, but we've been able to achieve that. And going back to previous deployments that we've done with X11 Twin Pro, for namely the Discover cluster for NASA, Goddard Space Center, we're actually continuing to expand on this cluster as well with X11, and we plan to expand the cluster even more. And one of the ways we were able to cool down those very powerful systems was by using a Motivair chilled doors. So if you go to our website, we talk a lot about our direct-to-chip liquid distribution with the manifolds as well as the quick connect hoses that will connect to a cold plate for the CPUs. But that's not for everyone. So with Motivair, we've been able to offer a little bit more flexibility. Even for customers that don't have a raised floor, we can offer quick connect overhead. But obviously if customers do have a plenum and a raised floor, then we can accommodate a quick connect from the bottom as well. So Motivair can now support up to 75 kilowatts per rack. So that's been a pretty good sweet spot for us because we can offer 50,000 watts of power very easily because of the amount of compute that we can offer, or even more if we have enough power available per power drop. So that's a little bit about the customers that we have for the X12 BigTwin as well as other multi-node systems.
So these types of environments that you're describing here, where performance is so critical, where scale is important, how do customers get insight as to how their applications are actually performing and scaling? And can you talk a little bit about that, these challenges in these large-scale deployments, how you help them overcome them?
Yeah, so from a building block approach, we get pulled in to provide consultancy for mostly the compute, the network, and storage. So we work hand in hand with our rack integration team as well as our product office department. And so they are working very closely with our field application engineers as well as our business development teams that are very technical, have a lot of experience in the HPC market segment. So we take a cue off of them, and they have site surveys, and they go into the actual data centers to really understand what are the challenges. And then from there, we're able to put together reference designs. So with all the experience that we have a comprehensive documentation that covers different InfiniBand network topologies or different power distributions from a lot of our partners, whether it be Schneider Electric or Rutten, Server Technologies, to offer telemetry as well as APIs that can tie into a rich ecosystem and single user pane of glass. Which brings me to my next point, which is we also offer a rack plug and play program where we're allowing customers to come to remote in through VPN access, so they're secured and they have the ability to run their own benchmarks, and it could be even a containerized application. So that's kind of the next evolution of Supermicro, really 3.0, is giving the ability for customers to run applications on a public cloud service or their own co-location or our private hosted environment to do lots of different workloads. So now we're not just talking about HPC anymore. Now we're talking about enterprise or partner channels where they want to help to run these benchmarks on behalf of the end client who may be doing data science, or they may want to just run some kind of smaller IoT device to see how it can actually do seismic measurements. And that ties into some of the bigger clusters. So they need to be able to move this information securely between all these different environments. So the rack plug and play program has been instrumental for a lot of our partners, really.
Isn't SuperCloud Composer a part of that too? Yeah,
so SuperCloud Composer is actually this our software that we developed in-house, and that is using standards to get telemetry using Redfish APIs. So that front end is basically the gateway to not just get telemetry, but even provision, do infrastructure as a service, analyze packets, analyze the network, the bandwidth, all these different things for the infrastructure side. And then you tie that into what we're offering in partnership with Red Hat and their OpenShift environment. They have their operator framework, they've got hybrid cloud technologies to move information between different object storage environments, and they have OpenShift Data Foundation, which offers support for file systems or block storage. So it's very flexible, and we're partnered with them, and it's going to evolve even more. And even the integration between our software for BMC, from the BMC level to the actual SuperCloud Composer, and interlaying that and providing a one user experience really with OpenShift and Supermicro technology, so that it's seamless for the end user.
So one thing I want to point out, just make sure, even though Michael's talking, this basically does apply to both SuperBlade and the Twins family. So this program is really across all the portfolio for Supermicro.
Yeah, it could be blades or twins or GPU systems. The SuperCloud Composer can basically provision lots of different solutions. It could be just bare metal operating system, or there could be a hypervisor and beyond that it can actually manage.
Okay. You already started talking about this a little bit, but I'm curious how you help your customers sort of design and build these HPC systems and solutions.
So Supermicro has a lot of expertise, and so yeah, taking to the next step, what Michael just described, where after they've been evaluating our systems and trying to decide, okay, which one that they want to move forward with, we have a team in Supermicro to help work closely with those customers, kind of identify the requirements, optimize the configuration for those requirements, and optimize the configuration at the node, the rack, the data center level, and do deep, thorough HPC cluster testing. Make sure that the system is meeting those application requirements that that they need us to deliver on.
Yeah, I mean, you said it. The cluster testing is very critical, especially with some of the newer chipsets that customers have never got to test before. So then, not only can they test on one system, they can see how their workloads can scale. Right. So that's very important, right? So we will have a lot of the switches on site. So once customers remote in, they can actually gain access to a high performance network, usually powered by InfiniBand or even OmniPath. So it's very important that our systems follow standards to support low profile cards, OCP 3.0, small form factor cards. Those are standards that we abide by when we're doing our building block solution design.
Very cool. So thank you, Michael. Thank you, Luis, for sharing this information about your sort of latest multi-node systems with us today, and their applications for HPC. So you addressed a lot of things. Is there anything that you still would like to address at this point?
Sure. So as we keep alluding to, Supermicro has a really broad portfolio, so we can't touch on all the products. It's just not possible. So I've kind of talked about the 8U SuperBlade, but we also have two other models, the 6U SuperBlade and the 4U SuperBlade. What's great about the 6U SuperBlade, it gives you access to a max memory footprint that those architectures can provide. So 16 DIMMs for a single socket platform, and 32 DIMMs for a two-socket platform in a dense blade form factor. Additionally, the single socket blade gives you access to two GPUs, two single width GPUs, or one double width GPU. So the 4U SuperBlade provide the highest density for the Ice Lake or Intel 3rd generation Xeon scalable processors. Gives you the highest density up to 140 server node in a 42U rack. So again, if somebody is focused, just on wanting the highest compute density, the 4U SuperBlade it's great for like EDA type environments. So just without reciting more specs, go to the website. There's success stories, there's white papers, there's a wealth of information online to learn more about our products.
Yeah, and if you've stuck with us up to this point, I want to share just like some golden nuggets about this node. So here you can actually see the 2U2 node. We actually have two impact connectors, so each one of the enclosures can actually support 2,200 watts of power. We have options for 2,600 for the 2U4 node, as well as even 3,000 watts. So an incredible amount of power that's available. And in this configuration, we're actually building out GPU support. So we can fit a double width GPU. We have additional pin out to support the power required to support an NVIDIA A100, for example. And you can see we have the 1U heat sinks. So imagine a hyper-converged GPU system with 12 NVMe drives, A100, very powerful CPUs up to maybe 205 watts just for the 1U heat sinks. That's a very powerful AI system right there. But even for customers that they're just looking for raw computing power, the 2U enclosure allows us to have taller heat sinks. So without liquid cooling, this gives this building block solution to offer a whole lot of value. Cooling down up to 270 watt 8380 processors, for example. That's the highest end, third gen Intel Xeon scalable processors. So, there's a lot going on for our systems. In summary, both systems offer a lot of different features, and there's pros and cons to each. But depending on the use case, reach out to us, go to supermicro.com, and work with your salesperson or your field application engineers, and we're happy to consult on these projects.
Absolutely.
Terrific. Thank you so much, Luis, Michael. Great stuff.
Thanks, Peter.
Thanks.
Learn more at www.supermicro.com/HPC, featuring third-gen Intel Xeon scalable processors.